Hi folks, we're going to take a look at number 32 on page 421. So they give us a quadrilateral with these vectors representing the diagonals of that quadrilateral, and they want us to show that ABCD is a rectangle. Okay, so let's figure out what it means to be a rectangle so that we know what we have to show. Okay, so if we have a rectangle, and especially if we're working with the diagonals, well, we can say that the diagonals have to bisect each other, because that's for all parallelograms. But in order to be a rectangle, not only do the diagonals have to bisect each other, they have to be the same length. Problem here is I don't know what A, B, C, and D are. So I suppose what I could do is, place these vectors. Place one vector at the origin, but then where do I place the other vector? It seems like it's just going to be too difficult to figure out what A, B, C, or to determine points for A, B, C, and D. So what I'm going to do instead is I'm going to try to determine vectors that represent the side lengths. Okay, and we realize that in order for a quadrilateral to be a rectangle, we need the side lengths to be at 90 degrees to each other. Okay, because the only thing you can get if the side lengths here are at 90 degrees to each other is a rectangle or a square. Okay, and a square is a rectangle, so I don't really even need to distinguish that. So the question is how do we determine these side lengths? So let's call them X and Y given the diagonals. Okay, so we know that the diagonals of a parallelogram, which a rectangle is a parallelogram, represent the sum and the difference of the two side length vectors. Okay, so let's even take something more general, say X and Y. Okay, create this parallelogram. Well, we know what one diagonal will be the sum and the other diagonal will be the difference. Okay, now the question is which of these vectors is going to be the sum or the difference? In the end, it doesn't matter, because if I place my vectors like this, X and Y, whereas if I place my vectors in this direction and create that parallelogram, we see that this vector here, which used to represent the difference, now represents the sum. Okay, and this vector here, which is the same as that one there, which used to represent the sum, now represents the difference. So it doesn't matter which one we use. That's what makes this problem fairly easy to do. Okay, so what we have is we have X plus Y. Let's say that's equal to this first vector, so 3, 3, 10. By the way, there's no need to work in standard basis form, easier to work in component form. And let's take the other vector to represent the difference, X minus Y. That'll be equal to -1, 9, -6. Okay, so the question is how can I use these diagonals to determine the actual vectors themselves? And this is where we essentially solve a little system of equations. Okay, so here we notice that if I add these two vectors together, what's going to happen? The y vectors are going to cancel each other out. So I'm just going to have 2x. Okay, again, I'm adding them. Okay, it's just going to give me the sum of these vectors. So 3 plus -1, so 2, 3 plus 9 is 12, and 10 minus 6 is 4. And so from here, I can determine that the vector x is going to be equal to 1, 6, 2. Okay? And I can do something similar to determine the vector y, because if I subtract these two vectors, the x vectors cancel out, and I'm just going to be left with 2y. So that's just going to be equal to the difference of these two. So 3 minus -1 is 4, 3 minus 9 is -6, and 10 minus -6 is 16. And so I can figure out that y has to be the vector. I just need to divide this by 2, so 2, -3, 8. Okay, so now what I have is I have vectors that represent the sides of this rectangle, and I just need to show that these two vectors are perpendicular to each other, and of course I'm going to do that using the dot product. So if I take x dot y, what do we get? 1 times 2 is 2, 6 times -3 is -18, and 2 times 8 is 16. Okay, and here we have 2 minus 18 is -16 plus 16 is equal to 0. Okay, so what we've shown is that the two side vectors that represent the sides of this quadrilateral are perpendicular, and that means that the shape has to be a rectangle. Okay, so just to recap how we did that is we figured out that because we're giving vectors that represent the diagonals, those represent the sum of the side vectors and the difference of the side vectors, and from there we were able to solve for the side vectors themselves. Okay, that's it for this one.